Hello friends, welcome to Susan and John MathTube. In this video, we will work out two problems from past papers and that also from the new syllabus. Okay, do not watch the video if you do not have the notes from lesson number 4. Okay, let's start. So it's clearly given we have a wave equation because the first line itself, a tightly stretched string fixed at two ends, x equal to 0, x equal to pi. So the picture looks like this: 0, pi is initially at rest in equilibrium position. U x comma pi, it is equal to 0 because it is at rest. Okay, and I understood one more thing. The length, usually it will be L, right? Here L equal to pi. Now let's read. If it is set in vibration by giving to each of its points a velocity del u by del t, etc., etc., etc. So we can write the initial condition from here. X comma 0 is equal to 0.03 sine x minus 0.04 sine 3x. Now don't worry, most probably we will not have to waste time calculating Fourier coefficient here because the condition is in terms of sine. Let's wait. Maybe you'll have to find, but most probably you will not have to find. Find the deflection. Okay, so I'm going to start like this. Let the solution be. Come on, pause the video, try to write. Or you can tell me the uxt value. An cos n pi c t divided by L plus Bn sin n pi c t divided by L, the whole multiplied by sin n pi x divided by L. Now wait a minute, this equation is going to be little bit simplified because L equal to pi. So u x comma t, our final solution is sigma an cos nct. Can you see? If L becomes pi, pi and pi will get cancelled, plus Bn sin nct, the whole multiplied by sin nx. So if you want, you can call it equation number 1 or you can use it further. And what's our job? To find An and Bn using Fourier, but most probably we will not use. Okay, I'm going for the first condition, ux comma 0. How do I get ux comma 0? I have to plug in t equal to 0. So obviously this will become 1, this will become 0 and this stays. So we get an sin nx. But the condition, initially it was at rest. So I can plug in 0 is equal to sigma an sin nx. From here I can write an equal to 0, but still I'll do a drama here. An equal to 2 by pi, because that's a length over here, integral of the function, and of course sine series, sine nx dx. Oh, this will be equal to 0, just for logic's sake. So we got an already. Now our job is to find bn. Okay, to apply the velocity condition, I have to differentiate with respect to t. So we get, when you differentiate this, nc is going to stay and cos will become minus an sin nct plus bn cos nct multiplied by sin nx. Can you see? The same thing. And the condition is ut x comma 0. So when you plug in 0, this will vanish, this will become 1 and this will stay. So we get nc bn sin nx. Okay, now the condition. If you look at the question, they're given 0.03 sine x. Okay, so let's plug in the velocity condition. 0.03 sine x minus 0.04 sine 3x is equal to sigma ncbn sine nx. By the way, if you're applying Fourier, this will be the coefficient, not bn, but this will be the coefficient. Anyway, I'm so happy we don't have to apply Fourier over here. So can you see, when I expand this, if I put n equal to 1, I will get 1 into c into b1 and multiplied by sine 1x. So I can write 1 into c into b1 is equal to 0.03. Think about it. And when I plug in n equal to 2, I will get 2 into c into b2 into sine 2x. But sine 2x is missing. So b2 is going to vanish. Or I can write 2 into c into b2 is equal to 0 because sine 2x is missing. Now when I plug in n equal to 3, because I can see the third node over here, I will get 3 into c into b3 into sine 3x. So I can write 3 into c into b3 is equal to minus 0.04. Or you can write directly, the first node is given, so 1c b1 equal to 0.03. The third node is given, so 3 into c into b3, and all other coefficients will vanish. From here, I got b1 equal to 0.03 divided by c, and b3 is equal to minus 0.04 divided by c, and all other coefficients other than b1 and b3 will vanish. Now I have to plug it back into the solution. So I'm going to get u x comma t, our equation number 1, is equal to sigma, that an will vanish. So you're going to get 0 plus, and then comes bn sine nct multiplied by sine nx. Okay, so u x comma t is equal to, I have to plug in n equal to 1 to infinity. So when I plug in 1, I get b1. So the solution will be 0.03 by c sine ct into sine x plus, now I'm not going to put n equal to 2 because it will vanish. Then I have to put n equal to 3. And when I put n equal to 3, this will be minus. So the solution becomes 0.04 by c sine 3ct into sine 3x. And that's it. Now let's go for the last problem. And it's a question they asked in 2081. The first batch in the syllabus. Okay. So can you see, solve the heat equation. By the way, we have already done this problem using separation method. And you can check, it was very, very long. So in this video, that separation of variable, first 3 problems, you can check the third problem was the same thing from 2081 Chaitra. But now look at this. I'm not going to use that long process. Since it is clearly mentioned one dimensional heat equation, I'm going to assume, let the solution be, come on, what will be the solution of heat equation? Sigma an sine n pi x divided by L, and the exponential decay minus n square pi square by L square into t. But can you see here, the length is here, value of L equal to small l. So I'm going to change this into small l. This will be small l and this will be small l. Okay, so this is the final solution. Now the initial conditions are given. So I'm going to apply u x comma 0, which will be obviously an. This part will become 1. So we get sine n pi x divided by L. And it is given to be u naught sine n pi x by L. So I'm going to write, by the way, get connected with us in Facebook, Instagram, and support us. Okay, so I'll plug in those conditions. U naught sine pi x by L. I just plugged in the condition, equal to sigma an sine n pi x by L. Super awesome, because we don't have to do the long process. We got the condition in terms of sine. And I know it's the first node. I can see n equal to 1. Or you can imagine like this. When you expand with n equal to 1 to infinity, you'll get a1 sine 1 pi x by L. So a1 equal to u naught. And a2 will be 0, a3 will be 0. Think about it. Anyway, I got an. And when I plug it back, I get the solution. I have to plug everything into this, right? I have only this a1 alive, a2, a3, a4, etc. all will become 0. So I get the answer u x comma t is equal to u naught, and what is the first term? Sine pi x by L, and e to the power minus, and by the way small l, n square pi square t divided by L. So substituting everything, I get the final answer u naught sine n will become 1, pi x divided by, it will become small l, e to the power minus 1 square pi square t divided by small l square. You can compare the answer with the one we did in the last video, plus 0 plus 0 plus 0 etc. So I'll be back with more videos like this, and in the next videos we will derive and solve the wave equation, and then derive and solve the heat equation, because these questions keep on coming again and again and again in your exam. So till then, my friends, bye.